Hi everyone, my name is Dr. Johnson and I'm a chemistry professor at USCL. Welcome to campus. We're so glad to have you here. I was asked to give you a few words of wisdom and pieces of advice on how to be successful in college. I really have three key points I want to share with you today. The first one is don't be afraid to ask for help. The professors here, our number one priority is teaching. We actually enjoy helping students one-on-one. So if you're stuck, if you have questions, if there's something that's not clear to you, seek out the help that you need so that you can be successful. The second piece of advice I have is take advantage of the resources that are available to you free of charge as a student at the University of South Carolina, Lancaster. This includes the PE Center, the Counseling Center, the library, Student Life, all of the different organizations you can participate in. Take advantage of all of these things while you're on campus. These are things that are going to help you succeed and they're going to enhance your experience as a student. And my last piece of advice is get involved. Build your resume, okay? Your future starts today, so you need to get involved. Join a club, and I would love for you to join our USCL Chemistry Club. I'm wearing the t-shirt, and I'm one of the faculty sponsors of that club. We visit high schools, we do chemistry experiments with students, we get together and have social gatherings, so we'd love to have you in the Chemistry Club. Another thing you should take advantage of is research. We have a research club where you can learn about what is involved in research and what types of research are out there and how it can help your career. And talk to your faculty members. If you're interested in English or history or chemistry or biology, talk to those professors. Find out if they're doing research and how you can get involved. Research is a wonderful thing to have on your resume. It shows that, again, that you're doing more than just taking classes. You're going that extra mile, and it's going to pay off in the future. So ask for help. Take advantage of the resources you have at USCL and get involved beyond the classroom. Again, so happy to have you here and good luck to all of you. One of my favorite things about chemistry is the opportunity to do chemical reactions. So I'm going to do one right now for you. What I have here is some mossy zinc, and you might know the symbol for zinc is Zn, nice and shiny, reactive metal. And what I have in the beaker is some hydrochloric acid, HCl. When you combine those two together, they undergo a single replacement reaction and they generate a gas. So you're reacting Zn with HCl. Think about what gas, what element is forming a gas from that combination. And as you can see, we have a lot of bubbles. We can see smoke rising. I'm going to go ahead and collect that gas in this balloon. Okay, so this gas is lighter than air. It's moving up very quickly. That's a hint as to what the identity of the gas is. We're going to give that a few minutes to fully react, and then we're going to try to figure out what this gas is by doing a test on the gas. Our balloon is getting bigger and bigger as more gas is being produced and collected in the balloon. One of the things we can do to identify a gas is to test some of its properties. And one of those properties is flammability. Certain gases like methane are flammable. Methane is one of the components of natural gas. Other gases like carbon dioxide actually will smother a fire. And so if the gas doesn't catch fire and it can actually smother a flame, then that would be carbon dioxide. Certain gases like hydrogen are very explosive. And so by actually testing with a flame, we can tell if the gas is hydrogen or possibly methane. So let's go ahead and do that. I have here a candle, and for safety, I put the candle on a yardstick so I can stand far away. We're going to go ahead and light our candle. Okay, and let's see if this gas is combustible or explosive. All right, that answers that question. You heard it go boom. That gas was definitely explosive. It makes sense that it would be hydrogen gas. So what happened? Well, we started by reacting solid zinc, ZnS, with hydrochloric acid, HCl, aqueous, and we formed hydrogen gas. How do we know we formed hydrogen gas? Well, in the balloon, the gas that we formed exploded when we set it on fire, and hydrogen is the explosive gas. And the other product was zinc chloride. This is a single replacement reaction because the elemental zinc is replacing or displacing hydrogen from HCl. Another topic we study in chemistry is acid-base chemistry. Acids and bases are kind of like chemical opposites. Acids produce hydrogen ions in solution. Acids can be very corrosive to metals. They're going to taste sour, things like vinegar, lemon juice, those are acids. Bases, on the other hand, produce hydroxide ions in water. You don't want to taste a base. They actually dissolve organic matter, such as human tissue. So acids and bases, being chemical opposites, actually react with one another in what's called a neutralization reaction. Neutral pH, a pH scale, is used to determine the acidity of a solution, and a neutral pH is 7. So we can use acid-base indicators to determine whether a solution is acidic or basic. So what I have here is some bromothymol blue, and this particular indicator will be blue in the presence of base and yellow in the presence of acid. At neutral pH, it will be green. So let's look at our solution that we have here and determine whether it's an acid or a base by adding some of this indicator. And I'm just going to add a couple of drops. All right, give it a little swirl. And you can probably see it has turned blue. What I'm going to do is add a little more indicator so we can intensify that blue color a little bit, and it'll be easier to see. Okay, so since it turned blue, do we have an acid or a base? You're right, we have a base. Bromothymol blue, the indicator, turns blue in the presence of base. Did you know that when you exhale, that you actually are exhaling a material that turns into an acid in water? And what is that substance? Carbon dioxide. So you all have acid breath, and so do I. So if I have a solution that's a base and I exhale acid, what kind of reaction is going to happen if I blow bubbles in the solution? Let's find out. Okay, it's turned a little lighter blue, but it's still blue. Let's keep going. By the way, when you do this experiment, you always want to make sure that you're blowing bubbles out. You're not sucking in, because we do have a chemical base in this solution. Okay, this is taking longer than I expected. Has it changed color? Actually, it has. It's a very, very pale blue turning toward green. Let's keep going. What do we have now? The solution's turning yellow. Let's add a little more carbon dioxide. And there you have it. The solution is now yellow. Bromothymol blue turns yellow in the presence of acid. So with the carbon dioxide that we exhaled, we did a neutralization reaction on the base that was in solution, and we turned it from blue base to yellow acid. All right, so what exactly happened there? We started with a solution that contained sodium hydroxide, a base, and that base turned our acid-base indicator blue. Bromothymol blue turns blue in the presence of base. Then we blew bubbles into the solution. Those bubbles contained carbon dioxide. The carbon dioxide combined with the water to form an acid, carbonic acid. So we have a base, blue, combining with an acid to form a neutralized acid. Eventually the solution turned yellow because it went from basic to acidic. And this is the chemical reaction that shows what happened. So here we have our base that was in solution at the beginning, turning the indicator blue. Here we have our acid. That acid was generated from the carbon dioxide in our breath and the water in solution. So our neutralization reaction between a base and an acid produced water, H2O, and a salt. In this case, the salt is sodium carbonate. In chemistry, salts are ionic compounds that contain a metal ion and a non-metal ion together. So what did you think? Was this interesting to you? Is this something that you want to pursue? So if the answer is yes, then by all means, sign up for a chemistry class this fall or spring. If it's not really your cup of tea, there's still things in science that can help everyone in their everyday lives. The method that we use is to make observations, ask questions, look for answers to those questions. And those are things that can help you no matter what your path in life is. So thank you for letting me spend a little bit of time with you today, and good luck to all of you as you embark on your college career. Thank you.